So welcome everyone to our class. And what I'm going to show you here is a mean trick you can do to someone. Well, also, let's imagine a world where we were running a device that was only going to run IPv6, not IPv4. By default, your router has IPv4 enabled. But if you put no IP routing, that turns off the ability for the device to even have IPv4 running. So if I go into interface GI, let's do show IP and brief real quick. Do show IP and brief. So let's do an interface GI 0, 0, 0. Watch this IP. If I try to put IP question mark and address, let's see if it'll let me put an address. It'll let me put an address on, but it will not actually route because you've turned off IPv4 routing. So even though you can put an address on it and bring the interface up, it will not do IPv4 routing. So if you ever really want to make someone have a bad day, do no IP routing on a device. But it does have a use. Let's imagine a router that's only going to be running IPv6. You could do a no IP routing, and you could do IPv6 unicast routing. And now that device will only maintain IPv6 routing tables and will only route IPv6. So there can be some uses for this. But however, in our world, which is typically almost all dual stack now, if we're running IPv4 and IPv6, we won't really have this very often. But if you don't turn that on, you don't get the ability to participate in the all multicast or the all routers multicast group. You also will not have well, actually none of this is going to work till I put a switch in here. So let me put a switch in here real quickly.
Along the same way that you're talking about having the IPv6 and IPv4, where they are talking about the stack, and then they're telling what page is that one. So where they have the both IPv4 and IPv6
dual stack.
Yes, that's one. Okay.
Okay. Dual stack, it would be any router that had both versions of the routing protocol running on it. So in other words, if I did turn IP routing back on, and so now if I do show IP int brief, you'll see do show IP int brief. You'll see that this router has the IP address of 192.168.12.1, so it's got an IPv4 address on it. And if I go into that same interface, so int GI 0, 0, 0. Oops, golly, I missed the 0/0/0, and I put in IPv6 address 2001 : ACAD : actually, let me do it the way they do DB8 : ACAD : 1:1/64. And I'm going to do IPv6. I'm going to put in my link local address. Address FE80:1 link local. All right. So now what has happened, if you look at this, if I do if I do a show IP int brief, you'll see it's got an IPv4 address on it. If I do a show IPv6 int brief, you'll see it's also got IPv6 addresses on it. So this is a router that is dual stack. It's running both both protocols, IPv4 and IPv6. Does that make sense?
Yes. I think I have one of those ones that show me the gigabyte 00, and then show me the VLAN is it's not up. I mean, it's not turned on, and but the first two is on, and anyway, I think it's unique. I mean, multicasting that might turn that one. I have to practice that one to see.
Okay. Here we can dig in by doing a show IPv6 interface G000. We can see that IPv6 is enabled. The link local address is FE80:1. It is part of these groups. You'll notice it's part of the all routers group and the local segment here. So these are the multicast addresses that it's part of. And so that's how, if you ever need to find out if it's part of this multicast address, and if you need to see that IPv6 is enabled, you can see it right there. Let me try something. I'm going to try no IPv6 unicast dash routing. Okay. Then let's do a do show IPv6 net interface G000. Still says it's enabled, but it's not enabled globally. You'll notice here, the way you can tell that is it's not part of those groups. Has not joined the multicast group that is for all routers because it's not turned on. As soon as I turn on IPv6 unicast routing, you'll see now it has joined those all routers groups. Okay, does that make sense?
Yes, yes, yes,
All right,
yes.
All right, so what I want to do, all right, go ahead. If you got another question.
Well, I know what you, because instead of going to the lab, I try to do like what you're trying to do now in the packet tracer. I'm trying to simulate the same thing that we have with PC, the A, and then the switch, then the router, and then the PCB. But in that way, I have to cable the, because instruction that they give to us is to cable the. And I was thinking, oh, but it's already been cable. I think that instruction need to be removed from the lab. And when we are doing it practically from the packet tracer, like you showed me, they'll have to use the 232 to jump, then I can make it to work in that way.
Okay.
Not from
Well, I'm going to walk through something today. What I want to do, are there any other questions before we get started today? Any questions? Remember, we're still going on, folks, until July 26th. That'll be the final day. You've got to be done with CCNA 1 by then, because July 27th is when CCNA 2 will start for you. You have lost access to canvas.stanley.edu, but you have access to Netacad and to NetLab. So that is, you can continue to work. I put a revised schedule out here for you inside of our class. So you can click right here. And we have we've already pretty much gone over module 11, but we're going to do a little bit of something I call today what I call a challenge lab. Ebenezer, I see you're not in front of a computer, so that's going to make it a little hard on you, but maybe you can do it after you go back and watch the video when we do a review on it. Next week, there are no new assignments, so you'll be able to continue to work. We will have our meeting on on Monday and on Thursday. We'll have our meeting on Thursday this week too, for those of you who want to come for labs. But what I want to talk about today is something that I do in my classroom, and that is many times I will walk into the classroom, especially towards the end of a class, and I will just draw a network on the board, and I will say, okay, class, now it's time for you to do this work. Okay. Actually, Ebenezer, if you don't mind, I'm gonna actually turn off your video, because I'm gonna turn my video off too, so we got more room here. All right. Now what I do is I walk into the classroom and I just draw a network on the board, and I say, okay, we're gonna do a lab. But what I want to do with you today is, if you're in front of a computer and you can, go ahead and open up Packet Tracer. I want everybody to open up Packet Tracer. If you're in front of a computer, Ebenezer, I know you're not. I saw you walking around campus, so that's not a problem. But maybe you can again do this when you're not in class. But I want you to work with me to build this, what I'm going to call a challenge packet tracer. Now, take yourself off mute if you have any questions. Make sure you're asking questions. But notice, just open Packet Tracer with no selected Packet Tracer, and you get a blank canvas, a blank screen. Now, you may need to log in, because Packet Tracer does ask you to log into netacad.com. So if you need to log in, you just log in with your normal netacad.com credentials. Maybe you can raise your hand when you get this up and running like this, or come off mute and say, I've got it running. And make sure I'm recording, folks, so I hadn't forgot that. Yep, I am recording. Good. All right. So I got one's got it running. This is what makes Packet Tracer a neat program too, in that you can use it for just little open practices that you want to do with your class. And it actually fits into many different things that you can do in class because it has so many different uses. All right. All right, everybody got it up and running? Okay, well now what we're going to do, we're going to now create a very simple network. And the way we're going to do it is we're going to just go down here to the bottom. We're going to click on our network devices. We're going to click on routers. So make sure you're seeing routers along the bottom here. So 4331, 4321, and we're going to drag a 4331, actually let's drag a 4321 router out here. All right, so see we got a router out. Then we're going to go down and click for their switches. Let's pull a 2960 switch out here. All right, then we're going to go and click on, once we got those two, our next item, we go to our end devices, which is right here. So, you know, if you hover, you can see it says network devices. That gives you your routers and switches. End devices, you can see this PC. So drag a PC out on the left and a PC out on the right. And once these four items are out on the PT canvas, so to speak, we need to join them together. So to do that, you go down here and find your connections lightning bolt, click on connections. And for the left side, we will use what is called a straight through cable. So we're going to go over and find a copper straight through, which is the third item over. And you'll click the router 0 and connect it to gig 001. And then drag it over to the switch and connect it to gig 01, gigabit 01. You'll notice it's down. The reason it's down is because the router interfaces are down right now. Then we'll go down here and click and get another copper straight through cable. Click on the PC, do fast Ethernet 0 to fast Ethernet 01. Now this one comes up because the PC is on and the switch ports are on. So you'll see it start to come up. This is called spanning tree. You'll learn about it in our future classes. But there's spanning tree that's running through the steps for spanning tree before it goes active. That's why you get an amber light there. And then on the right hand side, even though the router does support what is called auto cross, remember us talking about that way back in our section on the physical layer, we're going to create and grab a crossover cable and connect PC1's fast Ethernet 0 to the gigabit 000. When you're all said and done, this is what you should have. So I want you to come off mute and ask me if you have any questions, or and let me know that you've got this built out.
I had to boot up another computer that had packet tracer on, so I'm
okay. No problem.
So I have everything, but I think when you went to links.
Okay, I can walk back through the links if I need to.
Yeah, go do that real quick. Oh, somebody.
And this is which lab?
It's no lab. I'm building this. We're building a practice lab. We're building this is what I call a challenge lab.
Okay.
By the way, if you need to delete anything, you can always go to the delete item and you can delete items out, delete links. Just be careful because if you click on it, it will delete it. There's no, do you want to, or are you sure? It's just gone. Okay. So once you've got your devices out, we click on our connections tab, our connection item. We'll go to our straight through cables first, and we'll go to our router and connect gig 001 to gig 01. And we'll get our straight through cable again, and we'll connect the PC's fast Ethernet 0 to just fast Ethernet 01. And so that gets that side. On the right-hand side, we use a crossover cable because it's a little counterintuitive, because you would think since it's a PC and a router that they're unlike devices and you would use a straight through cable. but really you consider all the interfaces on a router to be a network interface card. So you actually use a crossover cable. You go from FastNet 0 to gig 000. And that is what we should end up with, is a network that looks like that right there. Okay, which if I go over here and draw it out, we'll have a router, we'll have our switch, we'll have a PC over here, happy little PC. There's our switch. There's our router. We got our crossover cable going to our other PC. You'll realize why I did this in just a second. All right. So this is the network we are building as part of today's class. And to do this, we are going to take the network 192.168.12.0/24. And we are going to subnet it so that we can support 100 hosts on this side and 30 hosts on this side. And then we're actually going to configure it, folks. So we're going to do a quick configuration together. So this is what I call a challenge lab. Now, Denise, I love the way you said, which lab is this? The reason I do these types of labs is for that very reason. I want your students to not just do the labs that are in the curriculum. I want them to be able to go in here and be able to say, oh, I'm going to apply now what I learned in the curriculum to a new example. Now, this is very similar to something we've already done, obviously, because it's a very similar setup and format that we've used in our real gear and our other packet tracer items. But let's look right now what we've got over here. We've got one network of 254 usable hosts. So in order to get what we need to leave 100 hosts, we would have to look at our formula for, remember, 2 to the h minus 2 equals the number of usable hosts. So how many host bits do I have to support at least 100 hosts? Well, let's do this. To the 0, to the 1, to the 2, to the 3, to the 4, to the 5, to the 6, to the 7, to the 8. We'll have to go away for it. To the 0 is 1, to the 1 is 2, 4. Go ahead. Somebody got an answer?
Was it 7?
Yep, 7. Okay. So I'm going down here, 32, 64, 128, and then 256. So I've got to leave at least 7 bits, which tells me if I borrow one more bit, I'm leaving 7 bits. So remember, our value here is 128 when we borrow one more bit. So we break this into 0 to 127 and 128 to 255. Now I'm going to break the rules in what they teach in the curriculum. And the only thing it's not really a rule, it's a preference. In the curriculum, they would pull this portion out right here and use it for the network on the left. I'm going to pull this side out. So I'm going to take this right here and I'm going to bring it down here. And this side is going to be 192.168.12.128/25. What's the first usable IP address in this subnet right here? The first usable IP address would be
.129.
.129. So I'm going to assign that to the router interface. .129/25. And then we could do right here, we can make this one 30/25. And this could be just do 254. We'll use the final one for it because that's the final usable IP address. So now we can continue to subnet this network. We can go to a /26, which will give us 0 to 63 and 64 to 127. Still a little bit big because we got 62 usable hosts right here. Now, real world, I stop right here and I use this one, okay? Because I know if it's got 30 hosts today, it will have 60 tomorrow. But book world, I'm going to go ahead and do it one more time. So we'll do a 27, which gives me 0. This right here is being broken down to 0 to 31, 32 to 63. All right, so now I'm going to put over here, this will be the 192.168.12.32/27 network. First usable address is .33/27, and I'll use the same format for the last usable will be 62. So .62/27.
Okay, I have a question.
Shoot.
Okay, when I forgot which lab it was. And we were going through and you had to have two separate networks separated by the internet. Now the internet's going to have that little piece is going to have several devices that's going to be connecting both of those two segments. I had a little bit of difficulty, actually I still have some difficulty in getting those two separate LANs or WANs connected so that they can, so that you can do that cross communication between the two of them. And the thing that I couldn't really tell there was making sure that I had all of my connections set up properly.
Okay, well, one thing, let me just show you real quickly. Real world. Okay, so let's imagine this. Let's imagine that this is, you have a campus. Let's just say we have a campus in Charlotte, North Carolina, so CLT. All right, so we got a campus here. And let's say we have another campus here in Atlanta. Okay, so there's Atlanta. Now, what happens is we take these two campuses, we connect them to an ISP. Okay, so this is our ISP here. But out here is the ISP and the internet. That's supposed to be a cloud. It's just a real ugly cloud. Okay. Inside of here, there are routers all over the place. All right, so we got routers everywhere. Now, as far as there's a couple things that's going to happen in the real world. One is, more than likely, to Atlanta and Charlotte in the real world, this is going to appear as a solid link between Charlotte and Atlanta. Okay. Because what the ISP is going to do, the ISP is going to shield you from knowing what's in their cloud. They're going to use MPLS, which is multi-protocol label switching. They're basically going to make it appear like Atlanta's connected directly to Charlotte. Or they may have you do a VPN across this so that they are connected. So many times when you see a cloud in the middle, you will actually end up with this just being a single subnet. All right, not always, but sometimes. And then really this would just be a point-to-point link because Atlanta and Charlotte don't even know anything's out there. Now, I would need to know exactly what lab you were referencing to be able to pull the diagram up, but this in the real world is what we run into a lot of times. We also run into this sometimes inside of cities. You know, you got a building here, you got a building here in different parts of the city. And what you will do is you've got fiber and you'll just rent a piece of dark fiber and it ends up looking like a direct connection between the two. So you got fiber that you use. But does that help any at all? Because you're not going to be doing the subnetting for the ISP. Out here in the ISP, they're going to give you what they want you to have right here. And what they may even do is this. They may just have you worry only about this connection to right here and to right here, and they'll just handle everything internally. And that could be two separate subnets, or it could be, like I said, depending on how they're making this appear across the inside, it could be a single subnet.
I think that helps. I have to go back and look at that particular lab because I know we've had to add devices and things to various areas, and I had some issues with getting one configured to actually do the connection wirelessly. Okay. And so it was really it was kind of odd. It was like I couldn't, but then again, I'm also on a Mac, and so I'm not sure if it was just a Mac thing with Packet Tracer.
Shouldn't be. It should work pretty much the same. Do this for me. If you will find it and email me which one it is, and I'll go over it on the Thursday meeting.
Okay.
I'll do it in a Thursday meeting. That way, even if you can't attend Thursday, we'll at least have it. I'll go through it and you'll be able to see it as a recording.
Okay.
Yeah, if
Thank
you'll
you.
do that for me, I will definitely do that. That'd be excellent. All right. But now what I want you to do is this. I want you now to take this setup that we just come up with. We just subnetted this. And what we're going to do is we're actually going to configure the router. So let's go in here to the router. So open it up. We got our router sitting here. We're going to go into global config. We got to do our basic configuration command. So we'll give it a host name of R1. Okay. We're going to give it an enable secret class. All right. We'll do a line console of 0, line con 0. Remember, we only have one console line. Always put in login synchronous because that's just saves you a lot of headaches. We have to put our password in here. We'll use Cisco and we have to put in login. We'll set up our VTY lines. 04. I'm lazy, so I use the up arrow to put in the same commands that are available there. Okay. Now, I'm not going to put a banner message of the day in because I am being a little bit lazy. But if you did a banner message of the day, that would be something we could do. You also need to do service password encryption, remember, to encrypt your passwords inside of that running config. And then I'm going to go in here now and I'm going to check again to make sure I got my right interfaces here. So this should be gig 000, which it is. If you hover long enough, it will actually tell you which one it is. You also can accidentally disconnect it. So I'm going to gig 000, so interface GI 0/0/0. And I'm going to give it the IP address of 192.168.12.33, 255.255.255. What is /27? 255.255.255 dot. Remember to be 27 bits in the subnet mask. So I've got 24 so far. I need 3 more. Anybody? Brian, Glenda, Ebenezer? Ebenezer, you probably can't see it because you were having to walk around campus. 224. Okay. So we do that, do a no shut. Then I'm gonna go into my other. Now look how I use the up arrow. Like I said, I'm lazy. So I use the up arrow, go to gig 001, put in the IP address. And actually I could do this. This is the ultimate laziness. Just don't make a mistake here because it's so easy to make a mistake. Forget to change your mask. But now this is going to be 12.129. Do a no shut. Okay. Now I pretty much need to do a do right. So I'm save my configuration. So my router is pretty much set. All right. Let's go to this PC right here. And we'll go in and we'll put an IP address on it. So we'll put a static IP address 192.168.12.62. And our mask is 224. Default gateway would be the IP address of the router port closest to me on the same network, which in this case is 12.33. We do not have a DNS server. So let's go over here and do an IP config, make sure it took. Yep. Let's go ahead while we're here and just ping our default gateway 192.168.12.33. Yep, working. Excellent. So far, so good. Let's go to PC 0. And let's give it an IP address. 192.168.12.254. Notice it's trying to use the default mask also. And then we got to do 192.168.12.129. All right. Go to here. Command prompt. IP config is used to ensure the IP address has been set. Ping 192.168.12.129. Whoops, mistype 129. We have pingage to 129, and now I'm going to ping all the way across to 62, not 162 to 62. You'll notice now I am pinging successfully from PCA all the way over to PCB. So we took one network of 254 hosts. We used VLSM to pull out two subnets. Okay. We pulled out a subnet that we used for 100 hosts and a subnet we used for 30 hosts. There's your 30 host subnet. Okay. We then applied it to our devices. Now we haven't done the switch yet, so we could go in here real quickly. Now, I'm going to show you the one place that gets people in trouble on the switch. Give it a host name of S1, line con 0, pass of Cisco, login, line, wait a minute, login synchronous on the, and then line VTY 015, password is Cisco again, login, and then let's do interface VLAN 1 IP address of 192.168.12.130 255.255.128. No shut. Now let's see if we can ping from PCA, all right, to 12.130, which is probably going to fail, then be good, because it takes a little while for the switch virtual interface to come up. There we go. And that's real world. That happens in the real world too. So I can ping from PCA to this switch. Now I'm gonna go over here and see if I can ping from PCB to the switch. 130. Huh. I can't ping the switch. If I timed out. But now I'm able to ping. Let me try something. Let's see if I can ping PCA. Which, by the way, I know I can because PCA was able to ping PCB. So I can ping from PCB to PCA. I can ping the router interface of 129, which is on the other side, but I can't ping the switch. Does anybody know what I forgot to do on the switch? By the way, I did it on purpose. What didn't I set?
You did not set the route, probably.
Correct. You did not set the default gateway on the switch to point it here, because I can ping it with PCA, but I can't ping across or on the other side. So what I have to do now is set IP default dash gateway. It'll be the router port closest to me on the same network. As soon as I do that, you'll be able to see that I should be able to easily ping the 130. And it'll fail the first time, then it'll be good the next 3 times. You just gotta learn the MAC address. So that's all I had forgotten to do. I'd forgotten to put the default gateway on the switch. That happens so often. And it's just one of those issues that you need to be aware of, because students will consistently forget to put a default gateway on their switch.
I learned that the hard way with setting up a VMware virtual network.
Yep. That can, the virtual switches can get all kind of weird too. We once accidentally created a loop inside of a server using virtual switches, and that's bad, real bad, because it was taking our network down almost instantaneously when it would come up, and we'd have to disconnect it. But so this is a challenge lab. This is something that I did. I just had you pull up Packet Tracer, come in here, you pull these devices out, connected them together. Now, folks, you can create any kind of challenge lab you want. You could come in here and you could start adding devices. You know, you can add as many devices as you want. Now, this router right now doesn't have any more ports on it, but you actually have the ability, if you want to add additional add additional modules into your devices. So it's booting now, but you can actually turn it off. You can go to the back side of it, turn it off, and add in more ports so that you can use it. You have the ability to create any lab you want, which is really a neat thing to allow you to be able to do with this. I like doing this with real gear. I also like doing this with packet tracer, but a lot of times when I get real gear in the classroom, I'll come in and start drawing a network on the board, and I'll say, okay, here's what you've got to do. And I'll walk out of the classroom and let them work on it for 30 minutes without me being there. And then come back and say, okay, what did you come up with? And then that way they're having to apply what they've learned in the class. Questions about this little challenge lab? Is this something that you do in your classrooms? Is this something that you make use of? Something similar to this?
It's something that I do in my classroom, but not to this extent. The reason that we haven't been able to do it to this extent has been because we have not had the virtual environment to be able to do it in,
Right.
or like the pods to be able to use with the real gear.
Right.
We're in the process of getting our pods, working on getting our pods for the fall semester,
Good.
so that we have both the virtual environment for students to use and the pods.
Excellent.
And also one of the things that we've run into is that not all students' equipment is created equal when it comes to packet tracer. Because we have some students that have PCs, we have some students that have Macs, and then we have some students that do not have they have a PC, but it's not as, the word that I'm looking for, as robust.
Right. Well, one thing I am working on for you and for your schools is to have access to a NetLab system that will let you run packet tracer on a NetLabs. So in other words, like this, you could actually go in, and I have right now, this is packet tracer 7. That's why I'm not having all of you use it right now. The packet tracer 8 is coming out this week, I believe. But you basically just log in and you select a pod and do a reservation, and it boots up a small Linux box, and it also boots up a small firewall. And so once you're inside of here, you have access to a machine that has packet tracer preloaded on it in an environment we know works, so you don't have to worry about the students' machines not supporting it. That then has access to netacad.com, where they can go get their packet tracers and download them and do the packet tracers. So this is something that we will be giving access to you for the schools that we support, and you'll be able to get access to it and use it. So,
Okay.
so that will solve some of your problems there. Like I said, they'll basically, as long as they got an HTML5 browser, they're able to come in here like this, and they'll literally be able to come in and log in, and packet tracer starts up. You know, they can continue as a guest or log in with their actual NetAcad account. And then they will be able to do any lab that requires packet tracer. The only reason I haven't given all of you access to it yet is because we're still loading or still building the packet tracer 8 pods. And those pods will be available soon. As soon as they are, I'll give you access to them. But you can see here, it's the exact same thing we did or we have here. It's inside of NetAcad, or not NetAcad, it's inside of NetLabs. So you don't have to worry about the students trying to load them locally. This is something we had to come up with too for high schools, because if you have Chromebooks will not run packet tracer natively. So we had to figure out a way to make them run, and here it is. You basically just enable packet tracer. Oops, not there. Enable packet tracer on a device and give the student access to this pod. We've supported about 500 different students on this during COVID, who were using it because of the fact that they didn't have a PC that could support it. So that's coming for you. That's that. If you're worried about that, then we have a way to solve that issue for you. So hopefully that'll be helpful down the road. Okay.
One other question. I know that we were moving the date back for this particular course.
Yep.
So that we could get all the rest of our labs in. And I think I got an email message the other day that said that it was June 30th. I thought that it was sometime in July.
It is actually July 26th. It will be the final day that we have available. Let me pull up the syllabus again, the revision.
Just want to make
Here's the
sure.
revision that I posted. He said it's July. I've got the last week is July 19th, but that's the
Okay.
last week before the other class. So basically, I pushed everything back. So we're still, that's why we're doing this lab today. We're still kind of working on subnetting and getting you know, working on subnetting. Next week's no new assignments. So you actually are just working on catching up. Again, I will have class meetings, but we are just catching up. And then you'll see here, basically the week of the 19th is when you need to be finishing up everything inside of for our CSNA 1 class.
Well, I'm playing catch up, so I'm getting through stuff, and I'm finding as you see with some of the emails that I've sent you, I'm finding some nuances there within the Mac environment, and that's I'm kind of happy that I'm actually running this on a Mac, so that I run into these issues myself before I'm in class with one of my students that has a Mac. Because oh, it's doing, and I can't do my assignment because yeah.
Yeah, and there are some quirks with a Mac, no doubt. I'm hoping, again, especially for the CSNA 2 class, I will have you access to a packet tracer pods that you can use. So if you're running into big issues, we can get them to work. But it works for the most part on Mac. Actually, it works pretty good on Mac, to be honest. It just got some quirkiness. This is when your second class starts, CSNA 2 class, which is the same as the second cohort. We'll all be starting the same day, our second CSNA 2 class, which is pretty neat. All right. Any questions?
Did that show the start date is the 27th of July?
Correct. That is the start date for our second class. Yes.
That's a Tuesday.
It is, but that's just when we had to start it. You know, we won't have our class meeting until the following Monday.
Okay.
Because the reason being, you think about now, you pretty much know how the system works. So I'm not as worried about having a meeting on the first day of class on the 27th. Now, I will, if you want to be invited to the meeting with the other class, I can do that too. But we'll just meet on the 2nd of August. All you have to do really that first week is, again, sign into Canvas, do the intro assignment, and then we'll be in NetAcad and NetLabs working along just like we've been working along. So really for us, there's not a whole lot that changes.
It's just I have a standing 3 o'clock on Tuesdays that I can't miss.
That's okay. That's no problem. There won't be any problem at all. Our class will continue to meet on Mondays at 3. So, all right. Any other questions?
Yes, Kelly.
Yes.
Is there any type of way we can find out what portions we miss when we take the test?
The items that you miss, yes, there is a way. You can go in to, you should be able to actually underneath, let me unshare here because I don't want to show anybody's grades. When you take the exams and you get, well, let me go look here. You should be able to go into your grade book and click on the module exam that you took and see the items that you missed.
Okay.
You can do the assessment viewer, or actually it should be under you, it should be your student performance summary, but you should be able to see what you missed, yes.
Okay.
If you go in your grade book and then look at click on the item, the exam you want to look at, it should show you the questions and the items you missed and then what you put in. If it doesn't, Brian, I can meet with you and we can go through them one-on-one if you want to do that.
Okay. It's just a couple of them. I just, you know what I mean? I just wanted to see where did I go wrong at.
Okay. Yeah.
Nothing major.
I'm fairly certain though you can see it yourself.
Okay.
You just have to go in. Now, many of you haven't done some of the chapter exams. Make sure you're doing those module exams. So make sure, again, when we're inside the class itself, let me share my screen. Each one of these sections has an exam. So here's the first exam that everyone should be done with, this modules 1 through 3. Remember, you can take it up to 10 times. I'm not I'm using it for you to learn the material, not so much as an assessment item. So module 1 through 3 exam is right here. The modules 4 through 7 exam, and the modules 8 through 10, and so on and so forth. So you really should be already through modules 8 through 10 exam at this point. And then that way we'll be working through the rest of these 11 through 13, which we'll finish up in 2 weeks. Okay, so make sure you're taking those exams because those will help you learn the materials.
So is that where you said you can go see what you missed?
No, you should be able to look in your grades and completion. You should click there, and then across the top, you will see the name of this exam across the top. You can click there and it should show you what you missed. Okay.
Another question, Kelly.
Shoot, go ahead.
I know you said for the final, there's going to be a written exam.
Correct. That is this exam right down here. This is the final exam right here.
Okay.
So you'll click on it and take it just like you do your chapter exam. So that's your final written exam.
Okay.
Now, your final hands-on exam is inside of NetLabs.
Is that the 16?
Nope. There's inside of here when you see the when we go into our class now. So it's our class. This CCNA 1 B7 skills assessment MDP. This is your hands-on final. So you click here and you schedule it. So that's the final itself. And use the first subnetting item in the exam. And I actually went over that last class. So inside of here, there's the exam itself, but there's a series of subnetting questions. You use the very first one, which is the 192168 subnetting example. But that is your hands-on exam. And I'll go back over that again before class ends. But that's the last exam you'll take. The neat thing is I can then go in and look at everything you did on it and you're able to do it. So this right here, we use this skills exam equipment, but it's not inside of NetAcad. It's on my NetLabs because that's where our real gear is. Okay. If you have, by the way, gear in your classroom, you would be giving this exam right here, hands-on inside the classroom. And you actually have, as part of your course resources, once you finish this class, you will find out that there is available to you a skills assessment right here that is the actual hands-on exam that you give to your students inside the classroom. And it's got the hands-on exam and it's got the answer files to it. So if you you can look at both of those.
Yep.
Okay. So for us, we do it in NetLabs, and that way I can grade you on NetLabs. Be aware, I did mention last week, tomorrow begins, in fact, it's going on starting right now. Today starts our National Skills USA contest. And so tomorrow from roughly 9:30 till about 6, we will have most of the NetLabs pods in use for the National Skills USA contest. We're doing it remotely. And that will be true tomorrow and Wednesday. So just be aware of that we will probably be using most of the pods during the day tomorrow and Wednesday for Skills USA. As we finish up grading pods, we'll release them back to folks to use. But just be aware it'd be a little hard to find a pod to use for tomorrow or the day after. Typically, we're actually down, well, this year would have been the first year in Atlanta for Skills USA. But we've been in Louisville, we've been in Kansas City, but we've been national judges for somewhere around 10, 12 years. So we actually run that, we write the contest for the national contest. So, okay, any other questions? Well, everyone, that's all I've got for today. Denise, please send me that lab so I can go over it on Thursday.
Yes, I'll get that to you.
Our lab group. And if anybody else has any questions, please let me know. Otherwise, let's just keep working and let's get everybody ready to go and get through this CCNA 1, and we'll get into CCNA 2. And then, like I said, I'm super excited about where this is leading. It's to me, it's a great opportunity for me and for everyone to really help a lot of people. And that always excites me. I like I like to know, I don't get to teach students in the classroom anymore. So it excites me to know that each one of you is going to go out and teach students, and then that way I'm having an effect down the road anyway. So, all right, everybody, thank you so much. If you do have any questions, please let me know. I'm going to stop the recording.